So today, obviously, we're doing triangle congruence proofs. Basically, we're taking what we were just doing and writing a formal proof explaining our process. That's all that we're doing here. Now, before we open up our foldable, before you even start writing your 2-column proof, what should you do first?
Yep.
What should you do first? Do what with, yes, mark the parts congruent. Mark the parts congruent, it tells you. So on the front of your foldable, I want you to write, first, mark parts congruent. Yes, in the picture. That's what you should do first. All right, so today we're doing triangle congruence proofs. We're not doing this bottom part. We're doing that next class. CPCTC proofs. That's next class. So open up your foldable and we'll start with the easiest proof imaginable. It says given J is congruent to M, angle J is congruent to angle M, JK is congruent to MN, and angle K is congruent to angle N, prove JKL is congruent to MNO. So what should we do first? Mark it up. Okay, so is angle J marked congruent to angle M? Yes. Is JK marked congruent to MN? And is angle K marked congruent to angle N? Is there anything else in this picture that should be marked congruent that isn't? Like a reflexive side or vertical angles or parallel line angle pairs? No, there's none of that. So now that I have all the parts marked congruent that are congruent, what do you think I now do? Not yet. What did we do now? If it hadn't said this, what would you do next? Yeah, how? Yes, label the sides and angles with S's and A's. So I have an arc mark, an angle marked congruent to M, another angle. And then I have a side marked congruent to a side and an angle marked congruent to an angle. So how does this left triangle read? ASA. How does the right one read? So boom, we know that these two triangles are congruent by the ASA postulate. So now I can start writing my proof.
Wait, what do you mean by postulate in the other thing?
What?
What do you mean by postulate in the other thing?
A postulate is something that is taken as truth without having to be proven. So what do I write first in my proof? My given. So angle J is congruent to angle M, and JK is congruent to MN, and angle K is congruent to angle N. And how do I know this is true? Hold up. How do I know that given is true? It's given to us. So, what did I do after I checked that all the givens were marked congruent? What did I do? Mark them with A's and S's, and I realized that these two triangles are congruent by ASA. So boom, I can now state that triangle, that's it, triangle JKL is congruent to triangle MNO, and how do I know? By the ASA postulate. And I'm done. Postulate, yeah, ASA postulate. That means I'm done with the proof. So this is the easiest proof you can get. A two-step proof is the easiest proof imaginable. It'll get a little harder, yeah. So now, any questions on this proof? Now, I want you to copy this proof down on page 26. So these notes are going in on page 25. So you're skipping a page for these notes. And on page 26 is proof practice. On page 26 is proof practice, and copy down this problem and write the proof. Before we start writing this proof, what should you have done?
Mark the given.
Beautiful. Mark the parts congruent it tells you in the given. So it says AB is congruent to DF, and then it says AC is congruent to DE, and BC is congruent to EF. Then what do you do?
Mark the letters.
Yeah, mark with S's for our congruent sides, and you can clearly see that these two triangles are congruent by SSS. Beautiful. So now what do we start doing? Writing your proof. With statements and reasons. And because you already solved this problem, I'm just going to roughly sketch out this proof. I'm not really going to write down the given. You should have already done that. And we know it's true. Why? Good. And then what should your second statement have been? Beautiful. Triangle ABC is congruent to DEF. And how do you know that's true? Because of the SSS postulate. Good. Have I proven what I set out to prove? So am I done? Yes, I am. Good. Any questions on this type of proof?
Are we just going to get a practice question for every...
Okay, so example number 2. We're given BC is congruent to DC and AC is congruent to EC, and we're asked to prove triangle ABC is congruent to triangle EDC. What should you do first? Mark the parts it tells you in the given, which it already did for us, right? BC is congruent to DC and AC is congruent to CE. Is there anything else in this picture that I need to mark congruent? Yes. What is it? Your vertical angles. Perfect. So I'm going to mark my vertical angle congruent to my vertical angle. Now what do I do?
Oh, would you do... Yeah.
You label with your S's and your A's. And how does the left triangle read? S-A-S. And how does the right one read? S-A-S. So therefore, these are congruent by S-A-S. So let's go over this one more time. First, I checked that my given was marked. Then what did I do? Marked the vertical angles congruent. Then what did I do? Labeled and figured out that these are congruent by SAS. So how many steps do you think are going to be in this proof? 3. Given, vertical angles, and then the congruence postulate. That's it. All that a proof is just more formally writing down your process. So let's do it.
How do you label the angles that are congruent? They don't have... Like, in your statements part, how do you label that they're vertical?
I'll show you. Yeah. So, number 1, we always write down our what first? Given. So, BC is congruent to DC, and AC is congruent to EC. And how do I know this is true? Given. It's given to us. Then, after I checked that the givens were marked congruent, what did I then do? I marked the vertical angles, right? These two vertical angles are congruent. What can I name, or how can I say that these two vertical angles are congruent? What would I name this angle right here on the left? AC
ACB.
ACB, right? ACB. This angle right here is ACB. Remember, when I'm naming angles, what's the only thing that matters? The middle letter is where the angle actually is. So using 3 letters, this angle right here is termed ACB. So, step 2, angle ACB is congruent to, what can I name this right angle over here? Yes. Oops, where am I going? It's congruent to angle ECD. What else could I have called it? DCE. Either one is correct. Yep. As long as C is in the middle and you're naming the ends of your 2 rays. And how do I know this is true? From my guide to proof heaven, if you remember. Yes, where is it? Oh, I forgot to copy it on this one. Oh, it's all right. You guys should all have your guide to proof heaven. What on the guide to proof heaven deals with vertical angles? The vertical angle theorem. After I marked the vertical angles congruent, what did I then do? I used S's and A's to figure out that these 2 triangles are congruent by the SAS postulate. So what should I state as my statement for that third, statement? Right, and what does it say in the proof?
Triangle ABC is congruent to triangle.
Beautiful. Triangle ABC is congruent to triangle EDC. And how do I know this is true now? By the SAS postulate. Am I done? Why, yes, I am. I proved what it asked me to prove. Any questions on this type of proof? All right. So now you guys are going to try one just like this. Are you all done writing? Okay. So copy down this number 2. Number 2. And solve number 2. Write the proof for number 2. So first thing was what? Good. Mark the parts congruent that it tells you in the given. So angle T is congruent to angle N. And what else? TAB, which is where?
The left side of A.
Left side of A. Good. TAB is congruent to NAB, which is the right side of A. So now we've marked the givens. What do I now do?
Draw a line.
Where?
At the A.
Right. The reflexive side is congruent to itself. So now I label this with A's and S's. And how are these 2 triangles congruent? AAS. So now I can write my proof. I'm again just going to quickly sketch it out. Statements, reasons. Of course, you first write your given, and we know it's true because it's given. Then what did you say? Right, the reflexive side, BA, is congruent to itself. And how do I know it's true? If you looked at your guide to proof heaven, you found that there was a reflexive property, right? And then what could we then state? Right. We can state TAB is congruent to NAB. And how do we know it's true? By the AAS postulate. Could someone let him in? Thank you.
Great.
I'm going to finish up these last 2 proofs, and then you guys have one more proof to do, and then that's it for today. We do have a homework. It's only a half sheet with 2 problems. All right. Number 1. Example 3. It says WX is parallel to YZ, and WX is congruent to YZ. And it asks us to prove that triangle WXZ is congruent to YZX. So the first thing we check is that the given parts it tells us are congruent are marked congruent. So here we have WX is congruent to YZ. Are those marked congruent?
Yeah.
Yes, they are. Right here. What else can I mark congruent? The reflexive side is congruent to itself. Good.
Very good.
That's what I'm talking about. Keep going.
This is not what you're talking about at all.
And then YZX is congruent to ZX. Yes, good. Right? These two lines are parallel. We know these two lines are parallel, and this is our transversal right here. So, how do I know WXZ is congruent to XZY? They are alternate interior angles. Perfect. So now, are all the parts I know congruent marked congruent? Yes. So now I can mark with S's and A's. So I have an S, an S, an S, an A, and an A. So how are both of these triangles congruent? By SAS. Good. So now I can start writing my proof. I write my given first. WX is parallel to YZ. And WX is congruent to YZ. And how do I know it's true? It's the given. So after I checked that the givens were marked congruent, what did we then do? What did we then say? Before the alternate interiors, what did we mark congruent?
The reflection.
Beautiful, the reflexive side. So, what do I state here? Yes, ZX is congruent to ZX, and how do I know? By the reflexive property. Good. Reflexive property. Am I spelling that wrong? I am? Reflexive property. Then what did we mark congruent? Did we say? Yes. Yeah, WXZ is congruent to angle. Oh my gosh. Angle XZY. You could also call it YZX. Same exact thing. And how do we know they're congruent? Alternate interior angle theorem. Then what did we state? After we knew all the parts were congruent, what did we conclude? Yes, that a triangle WXZ is congruent to triangle YZX because of the SAS postulate. Good. Am I done? Yes. Two more, and then you guys do a practice problem. So this last problem is along the same lines as the previous, just a few more steps. So angle B and angle D are right angles, and AE bisects BD. Now, before we get into this proof, I want to point out we need to know parts are congruent in order to prove that the entire triangles are congruent, right? Does the statement angle B and angle D are right angles, does that explicitly say that B and D are congruent? So guess what? We need to state that they're congruent in our proof. And I'll show you how in a second, but just keep that in mind. So B and D are right angles, and then it says AE bisects BD. What does bisect mean? Cuts in half. Now, which line is doing the cutting? AE. So AE is like the saw, right? AE is the saw cutting BD in half. So what part should I mark congruent? B. Yes, BC is congruent to CD. Is there anything else on this picture that I can mark congruent that it doesn't tell me? Your vertical angles. Perfect. And now what can I do? Label. So my A's are congruent and my S's. So how do both of these triangles read? ASA. Wonderful. So now I can write my proof. And I write down my given first. I'm going to use shorthand because we're running out of time. And how do I know it's true? Good, it's given. Shh. So what was the first thing that we stated about this picture? What did we say? Before that, remember I said we have to explicitly state something. That because B and D are right angles, they are what? Congruent. So angle B is congruent to angle D. And what from our guide to proof heaven do you think helps us explain this? What on the guide to proof heaven deals with right angles? Oh my gosh, on the back, definition of right angle, which states that all right angles are congruent. Perfect. So definition of right angles, or of. Then what did we say? What did we then mark? Yes, we then said BC was congruent to CD, and how did we know? Yes, on our sheet, one of the things that deals with bisect is what? Definition of a bisector. Anytime you're dealing with the word bisect and you're trying to explain why the two parts that were cut in half are congruent, you use definition of a bisector. Now, number 4, last thing before we finish our proof, really. What did I then mark congruent? BCA is congruent to ECD, angle ECD, and how do I know? Why did I mark those congruent? Because they're vertical angles. By the vertical angle theorem. Whew. Am I done? Nope. What is the last and final thing I have to say? Beautiful. Yes. ABC is congruent to triangle EDC because of... You got it right. I heard you.
Well, yeah, what did I say?
You said ABC is congruent to EDC by ASA. That's what you said.
No, it's not.
Really? Okay. So you put a box and you're done.
I knew you were close, but...
And then, lastly, write this proof down. We didn't have time to do it during class, but you must, this is part of your homework. You must complete this proof. And next class, I will stamp it for you.
Yeah, I'm just down.